going on, everybody? How's life? Happy Wednesday. Sorry it's been a while since I've streamed. My computer decided to eat itself over the last week, so I had to rebuild it. But we're back in business, up and running. So today, what I want to try to do, I got a few more parts that I want to try out with the spinning pop bumper. Last time we got it pretty rock solid, actually. Here, let me switch over. So the cap itself, screwed into everything, is really rock solid. It's not going anywhere. In fact, I can hold this whole assembly just by the cap itself. Wow, and then it, of course, falls off the shaft. Neat. But the structural integrity of the whole thing is good. So I'm totally happy with that. What I'm not as happy with is we haven't been able to get it to speed up or slow down. So I want to try to add some speed control to this, and I bought a different breakout board. Let's see, this is a DRB 8871 motor driver. This operates on slightly different voltages and would support if we want to go up to a 12 volt motor instead of the 6 that's in here. Additionally, I bought a couple of other motors at various speeds because the one that we currently have in here is it's about as slow as you're ever going to want to go. So if we're going to be doing speed control, we need some actual speed first. So to start this out, we're going to try this. I cobbled this together right at the last minute. I got to go solder these parts up, and rather than making you guys wait and popping on later, I thought we'd try this out. So now we have Tinker Desk Cam, and no doubt really crappy audio over there. But let's go check it out and see how this goes. Okay. All right. Well, looks like the levels are fairly decent. I'll be looking at chat on my phone. Hope this works out. Okay. Looks good. Still got junk galore all over my desk. Start up the soldering iron. Okay, so what are we going to do? What are these? These are the 12 volt 140 RPM. Kind of got these as a backup. Let's do those later, I guess. I think these are the 6 volt 1000 RPM ones that I got. So we need to put leads on one of those. And this is I have no idea what this is. Let me do this. A smarter man would actually write this on these motors. So I can do that on this one. This is 12 volt 140. Let's see, do I have a smaller Sharpie? I do. Or if these will stay. Looks like getting a text from my buddy Jimmy. I'll let him know. Right. Okay, let's see if this is going to stick. 12 volt. What did I say? 140. I don't think there's really a good place to be writing this because pretty much everywhere on these motors is going to get some sort of friction. But we'll see. We'll see how it goes. 12-volt 140. Okay, good. That's sticking. That's good news. All right, and really quick, I do want to look up. Be right back. Yeah, so I want to look up my Amazon order, and because I can't remember exactly what RPM these were. Six volt 500 RPM and 12 volt 600 RPM. Okay, 6 volt 500. I've got to get this set up in OBS one of these days. Oh, 500 RPM. Volt 600. Here we go. Okay. I've been looking at the gears that are in all of these different sets, and the gears all appear to be exactly the same. I thought that maybe they were changing the gear ratio based on. We got a charging cable. I thought maybe they were changing the gear ratio to get different RPMs out of it, but from what I can tell, it appears that all that they're doing is changing the motor that's hooked up, which I found interesting. All right, let's see if that will keep my phone from turning off. This is not an ideal setup, but we'll do what we can. Get the soldering iron going. And 12 volt 600. Okay. Now everybody's favorite stuff. Let's cut some leads. Here we're gonna do 3, I guess. That'll work for now. Okay. I don't know how Ben Heck makes this entertaining, but he sure does. Although this is some brave content, putting out the soldering video. Oh, that's not good. My phone keeps on wanting to turn off. That's my only view into chat. See, can I easily turn? My settings. Screen timeout. 10 minutes. That'll do for now. What's great is I'm going to forget that I did that. Because of course I am. But that's all right. I'm not leaving my house these days anyway. Okay. I will try to do a little bit more of this on camera. I'm not used to just working in this small area, but we'll do our best. Okay, so let's go ahead and tin these. Probably should have kept them paired. Okay, those are a pair. And this looks like the long one, yeah. Pinning wires is just the best, isn't it? So anyway, after we're done doing this, I need to put some pins into this driver so that we can breadboard it up and see how well it do. My strategy for getting these other motors was to get another 6 and this driver board, because I'm curious if our PWM failure last time had more to do with not running the motor at full voltage, because we were doing it at 5. So maybe there wasn't quite enough juice for the PWM signal to actually do its thing, which is possible. It's also possible that just the driver that I happen to be using, I don't even know what it is, they're here. Is the chip labeled? An MX150B. Whatever. This one didn't work, so we'll try this other one. The one that we have here is a Texas Instruments part. I looked up the data sheet for it this time, and it should work. Also, I got some 12-volt motors just in case having that extra voltage helps with faster start. And if I go with the 12 volt, I have to use that driver because the other one that I have maxes out at 9, I think. And that would be no bueno. All right. At some point, I'm going to need to... Oh, hey, MPT3K. It is indeed. We're continuing along with it. I got some more parts to see if we can make it more better. And time permitting, what I want to do is start laying out a circuit board. Because the idea is going to be that I can fit this motor into the pop bumper cap, these tiny ones. And if I screw this into a circuit board, I can replace the incandescent lamp that's inside of the pop bumper with a ring of LEDs. Can you hear me okay, by the way? I think you should be able to. Cool. So we're going to be brave on stream today because I've never used Fusion 360's electronics package. It has one and it's based on Eagle, But I've done all of the rest of the limited stuff that I've done in KiCad or KiCad. But the nice thing is that in Fusion, which is where we've done all of the rest of our mod stuff, I should be able to extrude out a body and then use that as the PCB shape. So I can fit it exactly to what I want rather than having to measure and try and fail and all that. And for now, I'm wiring up these other these motors have different voltages and RPMs than the ones that we did last time. I wasn't able to do speed control, even though I thought I could. Measure twice, cut once, absolutely. Although it's funny, I do a lot of woodworking too, and I almost never use that adage. It's don't measure anything, put the other piece of wood against it and cut it based on that, because then it's perfect. So when this thing's done, if it works, I've got some ideas of how to hook this up. I originally was just going to do this as a TNA mod for George, and I guess Fliptronic, since he's got one now too, and he's close, so I can use him as my my QA testing. I mean, relatively close. He's 3 hours away, but it's not insurmountable. But what I've been thinking about doing is I looked up the specs of how Multimorph does their P-Rock boards, and the RGB LED that's in TNA in the pop pumper. Oh, okay, cool, dude. No problem. Lurking, bathing, feeding the kids. I get it. I'm still gonna explain all this. What was I saying? Now I've lost it. Oh, right. I was looking up the specs for the multimorphic RGB LED board, the driver board, and basically it just runs 4 direct lines to that RGB LED. It's 3.3 volts, and then RG and B pass to ground is what I can assume. I can hear you from the bathroom. All right, gotcha. So to change the color, you dim the one of the 3 colored RGB lights, and you do that with PWM. I'm sure it's not analog because we don't do that anymore. And what I was considering was I could just put a ring of LEDs around the pop bumper cap underneath and drive it directly off of those pins. But what I thought would be a more versatile mod and end up being a better thing to do in the long run would be to hook those up to analog to digital converters on a microcontroller, so that I can essentially detect what level it's trying to put the RGB LED at. And if I can detect that, then I can take over and do whatever logic I want to drive the LEDs. So my current thought is, wouldn't it be cool if there was a ring of LEDs? And I want to be able to set them to the color that the game wants, so I can read the values that the game is trying to set, and then I can in turn set that ring to whatever I want it to be. But additionally, I could program light chasers and different patterns going on in the top, and maybe that isn't great for TNA, but some of the older pins that don't have any of that logic or anything, like TAC for Mars, would be great if the pop bumper caps were constantly not only turning but had light chasers or blinkers or whatever. So that's the current plan. I guess you guys can kind of see what I'm doing from here. Uh, I've got parts graveyards around around the tanker desk and that kind of thing. So, oh, definitely an LE type mod. Yeah, maybe so. The neat thing about this though is that I do this at work too, and I'm looking at my phone like you guys are there. You're here. Hi. I do this at work too, where I can put together at least prototypes for these things for not a whole lot of money. I don't know how much mods go in the pinball universe because I don't even own a table. I'm building everything, and so far my non-functioning pinball table is the most expensive one I've ever heard of. But I would expect that after all of this R&D work is done, the actual bill of materials is going to be, I don't know, on the order of a few dollars once all is said and done. Which is pretty cool. But then to put that, in an LE, it's really the labor, I suppose. And I don't have any plans of selling this or anything like that. That sounds like work. This is just fun to get together. Give back a little bit, I enjoy watching my pinball streams from time to time. It's very relaxing. And it's fun to hang out with everybody. This community is fantastic. Well, I can't see my view count, but if anybody's in here and you're not following MPT3K, go do it. He's great. A simple light mod is how Pin Stadium got started. Well, okay. Sounds like that might be a thing then. Do they sell the Pin Stadiums retail? I've heard that you have to be a streamer in order to get one of them, but I don't know if that's actually true or not. Okay, I need to see if my screw terminals will fit in here, but I have to find them. There. Of course not. Fine. I need to get some more sizes of screw terminals, it sounds like. Okay, well, I guess these are just going to be pins. You can buy retail. I have them on all my pens. Cool. Do you use them when you're not streaming? I mean, are they just good to ramp up the GI of the pinball tables? I would imagine they'd be awfully bright. Okay, let's see if there's a better way of doing this one. All right, here we go. Are you serious? Dude, okay, well, I guess I should have known that these wouldn't be the same pitch. Well, that sucks a lot. Pin Stadium brand lights are available retail now, where... Oh, Roby99, hi. Welcome to the stream. I'm looking at my phone, you're the same color as MPT3K, so I didn't realize that there's somebody else talking. I don't stream, they're awesome. You can control the brightness. Cool. I mean, all of the pinball streams, not all, but most of them that I've seen like to have them on there, and it looks great as they're streaming. But I could also see that being good. What's racist? Oh, the same color. Yeah, great. With respect. Okay. Alright, you know what? I guess I'm just going to do this. This seems super dumb, but... I'm going to go ahead and solder a couple connectors on this thing. Yes, I know that's your humor. Although you're a lot more reserved on your stream, you kind of leave it to little bubblegum to make those jokes. Alright, where's... Okay, you gotta make sure the power is gonna be actual power. Okay, so we're gonna use this one. She does a good job of it. Every once in a while I'm watching and I kind of cringe, but yeah, she pulls it off. Should have this on. Just realized I've got all the solder smoke going in my face. It's alright. That's what this is, by the way. Yeah, you can buy them at the website, but basically it's just Scott building them. I kind of wondered if how difficult it would be to just get a, an LED strip and power it. I guess that's essentially what he's doing. Okay, I'm gonna double check one more time because I don't want to hook this up backwards. That's for sure. There we go. Right, but you don't have to be a streamer to get them. Makes sense. I don't know where I heard that. I definitely did somewhere. Here, I just realized I wanted. I'll go ahead and twist these. Come on, go molten. Penn Stadiums just have a really nice build, and the app controls lights. Yeah, no doubt. When I think about doing something myself and trying it out, it's mostly just often it's from a position of can I do it, but for almost everybody, it's going to be better to go ahead and purchase a product because it's faster. You don't have to do the work. It's been tested already, so you're not going to start fires. And often it's going to be a lot nicer than whatever it was that you could come up with in the first place. So part of that adage is, just how much is your time worth? This wire does not want to go through. Come on. Have I smashed it now? Yeah, probably. George and I were instrumental in helping Scott come up with Extreme version of the lights, as was Dead Flip. Well, that makes sense. What is the Extreme version? Oh, that's okay. Extreme. That's just his branding. Well, this is annoying. Now this is all frayed. And it's got solder on it. Yeah, the portable lights. Yeah, I remember Jack talking about them on his Dead Flip early on, but I kind of have stopped watching Dead Flip. The reasons why I was watching them kind of no longer apply. It's unfortunate, but it is what it is. Alright, I'm going to go ahead and cut this. And done a hell of a job mangling this lead. You're there. I think you got the prototype extremes. Well, if you want to have anybody QA for you, you might as well send it to the person that's got the biggest audience at the same time. And I bet that worked. I wonder how many of them he ended up selling because Jack had, was showing them to his audience. Why is this so difficult? When in doubt, add more solder. There, jeez, just find the hole. Still got a straggler, but let's try to snip that off, maybe. So right now, let me see if this will work any better. Well, there goes the battery. I'm going to try to turn on my actual work lights because now that I put that in backwards and then blow out this. Oh, yeah, I sure frickin' did. It's the exact same way that I did it before. Okay. That's still visible? Okay, I guess I want both of them on. But this way I can use my magnifying glass, which is on this thing. I just want to make sure that I didn't accidentally short these. Looks okay. All right, let's just get through this. Okay, the motor polarity won't matter because we're going to switch it anyway. Okay, oh, and of course, I got to twist this too. All right. Now, let's backfill this. All right. Final inspection, looks okay. Looks okay. All right, and that should probably do. I guess while I'm here, hopefully I didn't just shove the magnifying glass light right in front of the camera. That would have been great. Okay, while I'm here, let me go ahead and set this to 6 volts. Good. Turn it on. We're good to go. Clean it up slightly, which is ironic because this desk is an absolute disaster at the moment. All right, I'll see you guys back over there. Jeez. Hello. Okay. It seems so not bright over here now. Okay, so what were we doing? Let's get the 6-volt thing out. The faster one. What was this? 500 RPM. So this thing should just absolutely whiz. And I think it'll probably be fun to hook this up and watch it explode. Let's see, we can go with the old speed controller from last time. Still badly hooked up, or badly rat nested. Okay, screwdriver. Oops. Okay, what was I doing? Here we go. Need the smaller. I guess we can get rid of the Tinker desk now. Okay. And this was the 6-volt 120, I think. Actually, I guess I can look at that too, since I've got it up. What looks good? The stream? I'm still using my training wheels, unfortunately. 6-volt, 100 RPM. Okay. There we go. Okay. Oh, the pop bumper. Thanks. Yeah, it's surprisingly stable. Like it feels solid, even though these are just printed parts and they're held together with this tiny motor. Everything holds together really well. So I think this is actually viable. Ultimately, I'm going to need to use much thinner wires here, but this just happens to be what I've got. I might actually, now that I'm thinking about it, I might even use Cat5 cable, just network Ethernet cable for this, because it's nice and thin. Already comes in twisted pairs. Okay. So I think with the way that I soldered this, yeah, that sits really well. Cool. I had done some tests in Fusion already to see if. Let me go turn off that light and see how washed out that is back there. And turn off the soldering iron. Okay, so I'd done some tests in Fusion 360 to make sure that I could just lay a PCB flat on the top of this pop bumper instead of using this piece, and I can indeed. I also went ahead and bought a these are the smallest screws I've ever seen. It's ridiculous. But in here are some of the screws that I need to screw one of these motors to the PCB whenever I get it made. I guess these we can make longer. Let me try to keep my main desk at least a little bit tidy. Okay. Alright, so I've got this. What did I do? It's the speed controller. I just have this to test with. So I figure let's hook this up and see how ridiculous full speed is. It is entirely possible that this is going to blink apart because, let's see, what is 500 RPM? How many rotations a second is that? Is that 8? So that's a lot. This is going to be spinning for sure. Gotta feed the kids. Maybe see you later. Alright, man. Thanks for stopping by. It's always good to see you. We'll see you again soon, I'm sure. Oh, that didn't sit properly. It's too high up. What? What? Oh, interesting. I don't think that this shaft is quite as long as the first one. Well, that's a problem. So the set screw actually needs to be lower down. Yeah, we need to put this... I guess it wouldn't hurt if that was low anyway. Let's go ahead and move that. If I can find it. Is that this? It might be. Yeah, sure is. Okay, so probably that. It is. Let's not do that in the center anymore. But we do want it on that line. And put it there, I guess. So how far off? Let's do it from the bottom, I suppose. Use a little bit of space for a screw head. Okay. Rest of that work. I think that that's basically in the exact same place. If we go this far. Well, that's a little weird, but it's probably okay. Where was the chamfer that gave us that? It was that one. Okay. Get these as well. Okay. That'll do. That is a weird shape, but that's fine. I can revisit this and give this a flat here if need be. And at some point, it would be ideal if this was made of metal. Although making it out of this plastic, either nylon or this PETG, will sort of self-lubricate it. If it's rubbing against a PCB, the plastic won't actually tear up the PCB, but steel would for sure. All right. Well, I don't have. Let's go ahead and turn on little bits here. Unfortunately, printer cam has been replaced with Tinkerdesk cam, because I wasn't expecting to actually print anything out right now, but unload this. Sorry, I'll be right back. Okay. Well, at any rate, let's give this a shot anyway. It's not quite as fast as I thought it would be. So let's fit this on. Oh, yeah, that's going to need help. Let's see. Have any extra plastic? We can shim that. That's loud. Yes, thank you, printer. Oh, print server finally decided to come up on boot. That's great. Okay, now it's going to load. See if this is going to work. It's probably not the greatest of ideas, but we'll give it a shot. It's not going to take long to print this replacement, but it's not going to be instantaneous, probably 20 minutes or so. Yeah, alright. Yeah, we're just going to have to deal. Okay, so let's print this thing one more time. And do this with 0.2 millimeter. Yeah, and little bits. And PTG. Let me bring up Little Bits. Little Bits is the name of my printer. I've got 3 printers, and they're Little Bits, Morty, and Mr. Meeseeks. Hey, Ice-Q-Doo. Welcome to the stream. What was wrong with the previous version? Nothing. I got some new motors to try out, and the shaft is a little bit shorter, so the grub screw doesn't catch. And you were right, having that grub screw in there has been very helpful. Alright, so I can at least throw this up and we can watch that top right corner. So Ice-Ski-Doo, to bring you up to speed, I got some different motors and a different H bridge, because I really do want to try to be able to throttle speed on this thing, and with an H bridge I can also reverse direction. It wasn't working with the previous one, and I'm not sure if that's because I was running the motors at 5 volts instead of 6, because they'll still run, but their startup time is a little bit more sluggish, and that might have been enough to keep them from spinning with the PWM stuff. But the motors that I got seem to have a shaft on them that's just 2 or 3 millimeters that are too short. So I'm reprinting this part with the grub screw hole down another 2 millimeters. How long is this going to take? 16 minutes, no big deal. All right. In the meantime, I guess let's make a flag. Oh, okay. Yeah, that's not going to work. Shaft is way too small. Okay, well, I guess as we're doing this, you guys won't be able to see it spin for another 15 minutes, but we will get there. Okay, what was next? Here was our board from last time. Let's go ahead and hook up the old speed controller. Oh, great. Well, let's just pull the connector right off of the wires here. Cool. Probably also gonna... Well, if you guys love Solder Cam, got great news for you. Let me switch this back over. There we go. Okay. So now I just have to figure out where I put all of those connectors, and we will crimp up a new one. And they are here. Each seat of these. Get a couple of pins. Another housing. Where is that housing? I'm not going to do it now, but at some point I can take those pins out and reuse that housing. So, at least not want not. Alright. Let's turn this off so that these aren't live as I'm doing this. That's good. Just give it some brand new... Oh, I need that. Oh, I've got these. Okay. I have a good mind to go ahead and solder these, but then they don't fit in the housing, so I guess I won't. And these are probably... I probably made these way too long. Find out. Oh, I also don't have chat with me at the moment. Whoops. Let me fix that. Okay. Better. Did I miss anything? You have a different scene in your OBS with the keyboard area blown up big on one screen. Well, I think I might, but I'm still not even using OBS. I'm still just using Twitch Studio. Basically, because every time I go in there, end up thinking about 1,000 other things that I have to do in OBS, where I need to get all the audio mixing working and the scene transitions and all the everything. So I still have yet to actually hook that up. This is still too long. I've never used that before. It is extremely simplistic. It's Twitch. Twitch provides it. It's Twitch's app, and it's fantastic just for getting up and going. But as soon as there's something else you want to do, you're kind of out of luck. Like I can't change audio source volumes based on what scene I'm in, for instance. I can't change camera settings. I get whatever you get with the camera by default. And a lot of the time, that's a big pain. Okay, that looks good. Because with my setup, I get really washed out. I'm pretty pasty anyway. A little bit more on this. Nice tools. Thank you. I've done... been doing this for a while, but at some point I'll give a tour, I guess, of my workspaces. Because a lot of this stuff you might be able to see in the main cam. Oh, no, you can't. I'm tiny. All of these rack mount things are on a French cleat that I've got on the wall, and all of the enclosures are just 3D printed, which has been super handy. Because I can. Oh, I have to make sure that I put this in properly now. Just to the right, yeah. In general, I think it's better to have the right tool to do a job than to try to get something done in some sort of hacked way. Using some kind of wireless camera above your soldering area. No, not this time. I've got a ton of these Raspberry Pis. On this particular one, I have it set up where I can stream this camera, or I can plug a USB camera in here and stream that as well. And then typically I'll hardwire that. I'll put it into an actual Ethernet jack. I haven't set that up yet, so today I have a extension cable going from my computer all the way over here. Just a USB extension. I'm not sure how much solder cam people are going to be able to stand. But I know that there are at least YouTube channels that are entirely dedicated to just soldering, which is amazing. Trying really hard not to rebend these because it'll weaken the grab that the pin has on the wire housing. Oh, come on, just go. That in there? Okay. All right. Okay, we're back in business. See you guys back over there. Every time I move, I'm dodging cables and stuff. So we'll get that worked out at some point, I think. All right. So we are back to power. How much time we have left? We have 7 minutes left on this other part. Oh, I forgot to close Slack. Oops. And there it goes. Okay. Sorry about that. Okay, so that's our input. There's our motor. Okay, so we got a full 6 volts on this now. I doubt this is really going to make any difference, but we'll see. The higher RPM might help as well. Goes out to the motor, and we'll jumper that. Anybody have anything good happen to them today? I was like hearing stories of things not sucking in the world these days. Okay, I am going to go ahead and put a loose knot in here because I'm using alligator clips. What I definitely don't want is I don't want to short out these leads. And I've done that a few times. Okay, so let's see. Power's hooked up. I need to bridge negative here. Because I need to make sure that I've got a common ground for both the microcontroller and thing. Hey, Enra. Good to see you. Almost made it through Wednesday. Almost made it through Wednesday doing what? Okay, and we have to go back to code to look at what pins these were, 13 and 12. Oh, but those were on... Dang it. Okay. Amazon to the rescue. Heltec Wi-Fi kit 8 pin out. Oh, jeez. Just open the image in a new tab. There we go. Thank you. That is a tiny ass image. Okay. Work. Ah, nice. Nice to be done. I mean, okay. Good enough. Here we go. Okay. Currently, I have Slack minimizing to tray. Quit. Yes, thank you. There. Okay. Now we shouldn't get any more of those notifications. Okay. So what did I hook this up to? We did 13 and 12, which are pins D7 and D6. No, D8 and D7. D8, D7. Okay. cable. Okay, that power's still on. Okay, I haven't reflashed this, so this should start doing something. Oh, I had this hooked up to listen for um, the switch itself. And what pin did I put that on? 15, which is GPIO 0 D3. No, D8. I hate the way that they have this set up. All right, that's okay. These are the pin numbers for the microcontroller itself. These are the port pins. That's actually what I want on here. So my directions are 13 and 12, which are D7 and D6. Is that what I said before? I think it is. Okay, now we want we'll use yellow. Yellow into D8. Then we want to bring to we wanted to bring it to ground. I remember this being backwards and I couldn't figure out why. Let's see, 3.3. Nope. Also, nope. Well, that should be okay. Oh, yeah, that's not going to be good. Need to actually do that. I hadn't thought of needing this common ground with this thing. At least I think I do. Maybe I don't. Well, I must. Something just being powered just by this. This doesn't have a regulator on it, though. Okay, well, looks like we're going to have to rig this even more. Thought I had this all set up and ready to go, but I don't. Okay, so we got that. Another one of these. Now we can actually get our ground out of the supply. Oh, will the motor be spinning constantly or just spin after the pop hunters actuates? Possibly both. We will see. I would like to set this up where we can put in some logic and spin it when it hits, or have it slowly going or quickly going during, uh, like on TNA is the target game for this out of the box. So when it's time to destroy the reactor, it would be cool if it was going a lot faster. I have no idea why Google speech to text put a possessive apostrophe s at the end of actuate. I don't know. Okay. And this is jank. All right, so now that's common. Now I should be able to. Okay. That is now spinning. Both of these. That's good. So I want to put these back in 7 and 6. Oh, yeah, we need to plug this into either ground. Should be ground. Or okay, well, part's done in just the nick of time. Because it looks like I have this hooked up properly now. I need to get some shorter screws, these M2s, or use something else. Now that I've got those other ones, it might be better to use one of those, but I'll reprint it some other time. M2s. I guess we could keep that as a backup. Part's still good. Got some stringing on this. That's weird. Okay. Okay, well, this time I don't think we need the grub screw. That's on nice and tight. So, yeah, that's pretty cool. Well, this is hard to do without actuating it. Okay. So that you guys can get a better view of this. We'll go ahead and screw this back in. I can already tell that this is working better. I would like to see how slow we can go. Oh man, come on. I'm printing these without threads, which means getting them started the first time is tricky. I got the other one, but okay. Whoa. Here. There. Oh, did that bite? No? Okay. Well, time for a little post-processing, I guess. And I'll do this the real way instead of pushing on it. All right. Guess I need to chamfer this a little bit in the model. That would probably help. There are a bunch of strings in here too, which is going to make that a tight fit. I guess is good. All right. Man, that's a tight fit. We have pliers that can do this. Oh, jeez. I can even see in here that there's little stringy bits that are going to be interference for this. Am I actually... Okay. No, that should be all right. Yeah, I don't have any pliers up here that are big enough to do this. You can try from the other side. I'm not smart enough to understand string theory. Well, I ski-doo. String theory is pretty intense. I don't understand it all that well either. But 11 dimensions is pretty cool. Always cut away from yourselves, kids. Jeez. Things I do for my audience. Wow, this really printed bizarrely this time. There's a big old glob of plastic right there in the middle that is preventing the shaft from going all the way through. This is less easy to do in the dark as well. Get that. Literally like 4 minutes ago when you started poking around with that thing, I almost said be careful with those sharp implements of death. Well, thankfully, I must have hit a callus or something because I'm fine. But yeah, that could have been bad. I've had a lot of uh, pretty heinous shop accidents, I guess. They're not like sawing off fingers or anything like that, but I did drill into my finger once with a brad point bit. That was unpleasant. All right, I am clearly going to have to redesign this thing to open up. If we start from the top, can we get this in? Maybe not do that on my mouse pad. Although here you guys can't see it. Sorry. All right. Okay, I'm getting tired of this. Sometimes a hammer is all you need. Okay. Oh, that's why that was triggering constantly, because the wires are actually wrapped around the spoon switch here. All right, let's try this again. Well, if this works, I guess I still want to try this other speed controller. It should work exactly the same way, but it's rated at a higher voltage. It only has one output, which is fine, but it's a simpler design with. I think there's just a cap, and they put an LED on it for some reason. But if we use that as our part that we put on the PCB, it'll be less to buy, less to maintain. What was I going to do before I put these in? Not lose that. Oh. Thought I had a chamfer in the design for that, but it might not be enough. Also, I'm just using machine screws up here. These really ought to be little plastic screws, but I didn't have any this size. Yeah, so I think having this faster, just having this faster motor is going to give us success here. And I'm powering it with a full 6 volts. Though we could do that test. Just set it back to 5 and see how it goes. Okay. Nice and concentric. That was. There's power. One of them. Ah, this is the other. Oh, I had those backwards. Doesn't matter. It's just the motor. Okay. All right. Let's give it a shot. No. Oh, this came off. There's your problem. Okay. Okay, well, we can definitely go fast. Let's see if we can go slow. What was I doing here? That's right. Speed. How long I want to go, I think. And then how long the initial setup should be. And I think that's the duty cycle that I'm using. Yeah. Let's pass that in. No, whatever. We're going to put it here anyway. Start with 0. Okay. Oh, I probably don't have the right port number selected on this. Let me look at my devices. COM11 is what we need. See what we have set. COM11. Nice. Oh. Ooh, that felt good. Nothing like compiling on stream. It's great. Okay, let's get rid of that. Yeah. So if this works, this red piece I want to replace with an actual PCB, and on that we can put the ring of lights, ring of RGB LEDs all the way around. There should be enough room for the H bridge on there, and I figure that if we put the microcontroller below the table, then we could probably uh, control all of this with a I squared C bus going up there. So we would need on this board, what would we need to put through there? We need to go ahead and run the 2 wires for the I squared C bus plus 12 volt power or 6 volt power or something. Probably 12. And then put the step down regulators on there, and with the I squared C bus, we can put an IO expander up there. We can use that to. I actually have a few of those. I'm using one of them as the in my homebrew right now. I've got a driver board that I put together, which I don't recommend doing, by the way. Just buy one. But I want to learn these things, so. The chip that I've got on there is an I squared seed IO expander that has PWM built into it, and it's really designed for driving LEDs. But I'm using it to drive MOSFET gates, and the whole thing works fine as long as I don't actually use the PWM, because I didn't put gate drivers between the pins and the gates, which means that they swing too slowly. And at 48 volts, if I'm using PWM, it fries the MOSFETs. And I also forgot to put a fuse on the thing, so I cooked the coil already. What will be printed on the top, or will there be a toy on top of the spinner to get the spinning effect? Ice-Skidoo, I don't know yet. I don't know if you caught Fliptronic's stream the other day when they were doing 4-player head-to-head TNA challenges along with Cephalopod and I forget who else, but I noticed that only one of their pop bumpers had anything on it at all, and it was a little hazard tape pattern that was around the outside. But the thing that George had mentioned, and I think Jordan helped. I don't know, between the two of them. Somebody came up with the idea of putting a just a nuclear hazard symbol on the top of the pop bumper. So that could either be a sticker, or there's nothing really enforcing that you're using a pop bumper top at all. It could just be a disc or something. But I would think that what we would want to do is print out a sticker of something and put it onto the cap. But I'm kind of trying to do this. I'm doing this with TNA in mind, but I'm also trying to set this up so that you could put it in any pin that's got a pop upper, which is, almost all of them ever. Yeah, what was I doing before? We were doing this. We were doing code. Now that's weird. Hmm. What am I doing with speed in here? Nothing? Oh, nothing. All right, well, let's go back to, let's try doing, whoops. Let's try analog writing this again. Right, so that's, yeah. Okay, so we're ignoring this other stuff at the moment. Stop that. Go ahead and build again and see if this works. So I had kind of rolled my own PWM in the last stream because what I suspect was happening was that it was switching too quickly for the H bridge to actually do its thing. I want to try it again. We'll see how it works. And right now, I'm just trying full power, so I just want to make sure that the logic is right before I start changing values. So I don't know if you guys can hear that. Let's see. Nope. I hear it humming, so it's trying its best, but it's not actually moving. So let me see. Analog write frequency, is that what that is? Let's ask Lord Google. Not Amazon. What am I? Arduino analog write frequency. Set PWM frequency. So that's actually what we want to do. Base frequency for pins 9, 3, 9, 10, and 11. 31, 250 hertz. And it's double for pins 5 and 6. I don't know what pin we're using. Actually, this would be... do they have a way of asking that? Because this is an ESP8266. Well, it'd be nice if they just had this available someplace. Oh, no, not analog reference. Is this return? Oh, that's for the Arduino do. Okay, well, let's just try some stuff, I guess. So this looks like a divider that we're putting in there. Let's try 60. See how we do. Oh, we don't. Okay, so we don't even have that available. Oh, I guess we can just set the frequency. So what do we want to do? Let's try 60 hertz. I guess, or 120. No, we need to do way more than that. Let's do 10 a second. So 600. See how that fares. If this actually works this way. Because both of these driver boards claim that you can use a PWM signal to drive them. I suspect that just the duty cycle is too short, or well, rather the period on it is too short, and the duty cycle tells you how long it's on versus off within the period. But you know what I mean. Okay, well that's interesting. Um, I'm going full power. I think. What is analog? Let me look up the actual. What is the top value for this? Well, okay, if it goes from 0 to 255, why bother passing an int? Why not make that a byte? I mean, normally it wouldn't matter, but this is a microcontroller, and ints on Arduinos are 16 bits wide. I don't know, whatever, fine. 255 is supposed to be always on, and we are setting that, and we're going for second, right? So 1000. Yeah. Well, that's interesting because that might be hard to see. I can hear it more than anything else. It's taking a second for it. It's accelerating, I guess. And that time it didn't even go. All right, so it's better, but it's still struggling. Let's try this at half this and see if that makes any difference. Let's see if this is any better. What time is it? 8:36. Jeez. Well, unfortunately, I don't think we're going to get to the board design today. I didn't expect this to take quite as long, but I do need to figure out whether or not this is going to work. Where's the other speed controller that we soldered up? Did I leave it over there? Because I want to try that. Okay, that's way better. Way better. So what if we do 120 hertz? That'll be on off well, yeah, we're not going to be able to push it much. This might be a good argument for going for the 12-volt motor, actually, because um, the 12 volts will give you much more inrush current when you turn on the motor. I mean yeah, when you turn on the motor. So basically, it means it'll accelerate faster. Is what should happen. So this feels better at full speed. I'm curious if this, how this is going to do at all at lower speeds. Okay, well, that's pretty good so far. So let's put this, let's see if we can do this at half speed. 28. Oh. Might be a good idea if I source parts before we build the PCB. I guess somebody's going to want to sit there and watch me do that. It's super boring, just going through big spreadsheets of parts to find. Well, I guess we need that for the figure out what packages we need. I don't know. We'll see. Maybe we'll get drunk during that stream. Okay, well, it's trying. Hey, Jimmy, how are you doing? Okay, well, that's interesting. Half power is not actually getting us enough to go. Let's put this back to 360. What's causing it to struggle just because the speed is so slow? Um, I suspect. I mean, basically, what it is that the the motor itself needs a little bit of time to speed up, to spin up, to get the inertia to get going. And I think what is going on with just the way that I have this set up, that's not actually happening yet. Like, um, where's the driver board here? I don't know if you guys can see exactly what it is, but these little silver cans that are on here are big capacitors, and uh, I don't know, like I don't know what the schematic of this particular board is. So if those capacitors are on the motor side of the circuit, um, can you give it full power pulse for like 100 milliseconds, then cut the power lower as it continues after it gets its initial start? Yes, I can definitely do that. What I sort of envisioned for this uh, at one point was every time that you hit the pop bumper, it would spin maybe an eighth of a turn or so, a sixth of a turn, but do it almost instantaneously. Um, if I use a higher voltage motor, that should help with all of this because the higher voltage will uh, go through the coil faster. Um, did I upload? I did. Okay. Yeah. So just I guess just using the. All right. Let's give it initial milliseconds. Let's do this. Analog write pin 255. Delay for initial milliseconds, and then go down to speed. So let's set initial to 100. Let's see if we can still do this at half speed. So I'm sitting here thinking about this. If the RPMs are higher, that means that the motor that the shaft itself has less torque. Um, and less torque means it's going to take more for it to overcome the friction of just getting started in the first place. Honestly, it might help if I oiled the gears a little bit, but yeah, I think I might just want to try this other setup and see how it goes. Okay, well, we see it do its initial twitch. That's interesting. I changed two things at once, so just having the frequency at 360 makes this not go at half speed. Ah, okay. Well, see, is this guy actually wired up to where we can just hook it up? No. Oh, and the stakes voltage. Interesting. This I should just be able to. Okay, so I think that the power is isolated for the motor on this, so we don't actually need that common ground. Um, yeah. Is it a brush motor, and is there such a thing as brushless that small? It is a brushed motor, or well, I think. There may be brushless that are this small. This one of my viewers actually pointed me in the direction of this particular motor. I guess it's this form factor is used in tons of toys and things like that because you can get these in what I found. You can get them in 6 volts and 12 volts, and in almost any RPM that you want, like anywhere from I've seen as low as 40 up to 2,000, 3,000, something like that. Hey man, how goes the grind tonight? Hi, Riku. Or Riku Rinku. Yeah, sorry. Uh, it's good. We're kind of making progress, I guess. Um, I have not been able to get or change speed on this, and I'm still trying to figure that out as to why. What we're doing right now should work, but it doesn't. Um, but if we go at full speed, it works. It works fine. So maybe just having an H bridge isn't exactly what I need. They make electronic speed controllers, and I don't know exactly what those look like in a schematic. I thought that these would work. Building a variable code. I am while I'm building microcode to go to this um, ESP 8266, which is then controlling this H bridge, which is then controlling the motor that's in the pop bumper body, and all of that works. But changing speed is just kind of stalling out the motor, and I'm not sure why yet. Um, I think we're not going to have time to go and try to do this at 12 volts, but using Arduino, it's yeah, it's basically the Arduino environment. This is an ESP 8266, which is an expressive board, but um, I could be running this off of Arduino. I just happen to have this particular one handy when I got it. I've got a ton of these laying around. But I am using the Arduino environment inside of Visual Studio. That I use Visual Studio for work and everything else, and I like it. So I wrote uh, uh, an extension basically where it still uses the Arduino compilers and the Arduino environment, but gives me IntelliSense and lets me code in here. DC motor, yes, yes indeed. All right, so one thing that I'm noticing is that when the tape gets to about this location, it stalls a lot more. Like it's going nyeh, nyeh, nyeh. Check this. How to control the speed. Oh, yeah, perfect. Let's see what we're doing. Um, uh, there is supposed to be a flyback diode built into this H bridge. What have we got here? Or just maybe when you were pushing that piece down on the top, it might have messed it up. That is possible. If the shaft is bent at all, then that would do it. But uh, the concentricity of the pop bumper looks great. So it's not on a wobble or anything like that. Um, see what kind of it just says a transistor. Yeah, okay, but that's just going to drive to ground. Where is it getting the motor power just from the 5 volts? Yeah. Yeah, that makes sense. I mean, basically this circuit is doing what I'm doing, except that instead of setting this analog output to um, using it as a pot value. Oh, it's reading it. Let's see, and then it's switching this transistor. This PWM signal, I am sending this to the H bridge, and the H bridge supposedly can take a PWM signal and it's supposed to work, but um, I don't think you could bend the shaft. Yeah, the shaft anyway, but it might be possible to push the shaft and the parts slightly to the back of the casing, yet not visible to the eye. It's possible. Um, I think, yeah, probably my next step might be to try this at 12 volts or try this with this other controller. Um, I want to put this back at full power again, just so that we can look at it and marvel. And I think I'll call it for the day. Got some Overwatch to play and kids to be mad at. They're kicking my ass. I'm gonna drive a small motor at different speeds using an Arduino. Yeah, he's using a MOSFET. Um, yeah, I'll take a look at this too. We can try this out. The challenge, Riku, is that I need a separate power supply for the motor. Um, so I guess if they're just sharing ground, that's not a big deal. One of the things that I wanted to be able to do was select direction just based on whatever on software. And in order to do that, you generally use an H bridge, and that's what this tiny board is. This is an H bridge chip that can do 2 motors, and the directionality of it works just fine. Like I'll show you that now. Actually, I'll build this and do it, but um, doing the switching of the FETs that are in the H bridge is not working properly. So it's an important feature to me to be able to switch um, things. You should make a 3-dimensional Stranger Things topper that has the kids on bikes with a static street image behind it and 3D print a van that works on some slow moving cam that gives it a flip effect. Because the one that turned in, the one that Stern did is garbage. Oh, you mean something like this? Let's see. Yep. Yeah, this is a L298N H bridge. I don't know if I have those. I might have one sitting around someplace. Uh, but yeah, this is precisely what it is that I'm trying to do. This is what this board is supposed to be. And I mean, so far it works. And the reason why, incidentally, that they put these H bridges on these huge heat sinks is because as they're switching uh, between being on and off, they dissipate heat. So if you're switching them at high frequency, then they're spending a lot of time oscillating between on and off. Yeah, Ice Skidoo, I can put that in the hat of projects to do. Fliptronics still at some point, I'm going to help him with building some parts for his fire. Um, and but yeah, Riku, I'll keep this up and I'll I'll read through both of those just in case there's something that I'm missing. But all right, so there's your directionality. I mean, the at least we've got something that works for now. Um, I suppose off stream I'll start doing some more investigation of this and try the 12-volt motor, see if that makes much of a difference, and also try this different speed controller and maybe see if I can find something else in the articles that Riku just pointed out to me. But all right, well, I think I'm gonna go ahead and call it at that. Figure out somebody to raid. Mr. Scoot is on. Um, you guys don't know who Mr. Scoot is, hang out for a minute because you're in for a treat. Mr. Scoot's great. Go ahead and get that started. What is this, Riku? L2. Yeah, this is the same controller. I mean, if this is supposed to work, the other thing that I wanted to do is if one of these smaller ones worked, they're a lot easier for me to build a board for because I've got all of these other weird pins and this one takes a heat sink and all of that, so I've got to get all of that junk together if I put this together as a full product. But yeah, I'll give those a look. Anyway, guys, take care. See you next time. Thanks for stopping by, and yeah, have a good week. See ya.